So this video's just a bit of format and guidance with regards to Biomechanics Assignment 3. So as you can see, there's only two criteria, pass and a merit criteria. So producing a numerical model using three numerical components and compare it to support and performance with tutor support. So we look at the tasks. You need to complete biomechanical filming. You've done that, closed scale. So what we're going to do first of all is make the numerical model. So on the Blackboard site, the numerical model is by here, download it. Most of you should have completed this by now, but this is what it looks like. So whatever your closed skill is, put the title in there. And then we got three stages of skill. So there's three ways that I want to set out this model. You're either going to do it like this, with the preparation phase, action phase, and follow through. So let's consider a penalty kick in rugby. So if I was doing a penalty kick in rugby, the preparation phase, I need numerical concepts. So you're considering things like linear concepts, angular concepts, then considering things like displacement, velocity, accelerations, angles, things like that to go in these boxes. So what I might have is stride length, so the length of the strides I run up to the rugby ball. Another one might be acceleration of the run-up, velocity of the run-up, etc., etc. Now with the action phase, we're looking at things like angular displacement of the kicking leg. We're looking at things like angular acceleration of the kicking leg, angular velocity of the kicking leg, etc., etc. With the follow-through, I'd focus more on the projectile, so things like angular release of the ball, acceleration of the ball, velocity of the ball, etc., etc. Now, if you find it easier, you could change these. Instead of having preparation phase, you could have linear measurements, and then you could have angular measurements, and then you could also have projectile measurements in this one. So with the linear measurements, just look at your Excel sheet that we downloaded off Blackboards, where we put all the dartfish stuff in, and you can see all the linear things you measured. So things like linear displacement of the kicking leg, things like velocity of the kicking leg, acceleration of the kicking leg, etc., etc. So that's how you could do it. I'd prefer the first way, but if you find it easy, you can do it the second way. Once you've done that, you need to compare it to support and performance. So that's why we need these two sheets. So I've just developed random data between these two sheets. So I'm going to show you how I would pick between my elite and my non-elite. What I'm going to do is just splice the two files to either side. So what you need to be looking at realistically is the standard deviation, and you also want to be looking at the average. Now, standard deviation, the closer you are to zero, the more consistent you are as a performer. So I would expect my elite athlete on my left-hand side to have smaller standard deviations to my non-elite on my right-hand side, because the non-elite just can't do the skill as well. So we start looking down standard deviations. So for example, if we look at linear acceleration of the kicking leg, they've got a standard deviation of 69, but my non-elite's got a huge one of 433. So I'm definitely going to use that. So I'm going to highlight that. So now I'm going to use this. Now, if we have a look at the average column, because we're not just going to look at standard deviation, now there's some things where it's better off to be higher than the non-elite. So for example, acceleration of the projectile. So if you were doing football, if the ball's traveling quicker, you're more likely to score a goal because the goalkeeper's got less time to react. So if we look at the average here, we've got just over 1400, whereas here we've got just under 1100, so clearly it's much better. So I'm only going to use these two as the example. You need to pick 4 in total. What I must stress is you need to make the elite look better than non-elite. So I'm going to look at the acceleration graphs. So linear acceleration, and over here linear acceleration. Now if we look at these two graphs, actually our non-elite player looks a lot more consistent than our elite player does. Now this is because if you look here along the y-axis, they're not starting from 0, so we need to make these start from 0, because then what it'll do is level the graphs out. So we click on that, give it a double click, this comes up, put minimum of 0 and come back, and it gives you then the true value. We come here, click on this, and like the other one, give it a double click, and then you want 0 again. And once you set the 0, and then it sets all your bars together. So because we've got such high numbers, that's what's caused it not to be so obvious, but you can clearly see this is much, much closer together than it is here. Also, these little error bars by here, they're called, they're your standard deviation, so you can clearly see they're bigger than there. So therefore, our linear acceleration is much more consistent with our elite athlete. Now, the other one we were looking at was acceleration of the ball, just right at the bottom. Keep going down. We just got the same issue again. So next one down. This one does start from 0. Shows quite a bit of discrepancy. This one shows a lot of discrepancy but doesn't start from 0. So click there, double click, start from 0. And you can then clearly see they're much more consistent. Not only that, they're scoring higher as well in terms of acceleration of the ball. So it's a lot to talk about. So what I would then do, I would grab these two graphs and put in a Word document side by side. You need to just talk about how it benefits performance. Now, it only needs to be about 3 lines. So you would talk about how with the ball going faster, more likely to beat the goalkeeper because they got less time to react. Also, less time for a defender to be able to block the ball. That's pretty much all you need. Up here, the way I would talk about the linear acceleration. So I would say, as you can clearly see from the two graphs above, my elite performer is much, much more skilled because they have less variation between 3 attempts. However, my non-elite has a greater deal of variation. It shows they're not that skillful, therefore they can't repeat the skill. Therefore, they're more likely to miss the target because they can't repeat the skill consistently. And that is all you need to do once you've done 4 different sets of data. Right, once you've done that, you need to include your biomechanical filming methodology. And you've all done that already in assignment 2. So if you're only going for pass, you need to go no further than this. If you're going for merit, the only way you get merit for this is at the end of this PowerPoint. So this PowerPoint is here on Blackboard. Now, justification of method. You answered these 1, 2, 3, 4, 5, 6, 7 questions, and you will get a merit. So this is the only reason I really put the exemplars on Blackboard. But we'll go through them quickly now. So why have you set the camera up on a specific side? Well, if you're looking at right-footed players, you need to see their right leg, or right-handed, you need to see the right hand, because otherwise you won't. Their body will be in the way, so you can't get angles, can't get true readings, and you lose reliability, validity, and accuracy. Beef that up a little bit, but that's the main reason. Why have you used markers? Again, this is all for accuracy, reliability, and validity. Clothes can move, so if you're looking at fixed points, clothes can move. But if you use markers, you can consistently see the points on the body that you want to mark, making you more accurate. Why did you scale the image? So that's where you put the 2-meter cones on the floor. Dartfish doesn't know what a meter is. Unless you tell Dartfish what a meter is, you can't have an accurate measurements. You can't. They're not reliable. They're not valid. Everything goes back to accuracy, reliability, and validity. Have you minimized perspective error? So what perspective error is? You think about watching like a football match or like a hockey match, anything, and you're sat on the halfway line, and you look down to the goal, and someone shoots, and then someone clears it off the line. Now, some of the players are claiming it's gone over the line. You can't tell because of the angle you're at. So that angle is called perspective error. You can't quite see the angle. You could only see if it's crossed the line if you're dead in line. So you minimize perspective error by putting your camera dead in line with the skill being performed, which allowed all your readings to be true, accurate, reliable, and valid. Considerations you made to the background with things like you made sure no one was in the background, you made sure there was no contrasting colours, allowing everything to be accurate so you could track things like the ball all the way through. You selected 3 trials because your non-elite could just fluked the first one. By having 3 trials, it allows there to be the consistency for the elite and no consistency for non-elite, so you can see clear differences between the elite and non-elite. And you looked at success as well because your non-elite, may have been very consistent in their technique. However, they may have missed all 3 attempts, whereas your elite person may have scored all 3. And it's just another way of showing how your elite performer is better than your non-elite. Once you've done that, just put that on, upload on Blackboard as normal, and then Biomechanics unit is complete.